Historically, programming has been seen as an intimidating task, solely reserved for computer whizzes and IT practitioners. However, today, with the rise of tools such as Python, it's becoming far more accessible. As such, today on LokadTV, we're delighted to welcome back Nicolas Vandeput, who's going to discuss with us just how simple it can be and what we can learn from his new book. So Nicolas, thanks very much for joining us again today. As always, we'd like to know a little bit about our guests and what they've been up to. So what have you been up to since we last saw you on the show?
Hello again. Hello, Joannes. Well, actually, as always, I'm busy working on creating some nice models for companies on inventory optimization and forecasting. Yeah, and well, I cannot lie, I've also been writing some books and teaching at university. As you know, that's my big hobby now.
Okay, lovely. And today we're going to be discussing one of those books, Joannes. It's called Inventory Optimization Models and Simulations. So what is it that's different about Nicolas's book?
I think, Nicolas in this book is embracing, I would say, frontally the one thing that I believe to be a cornerstone of modern supply chains. And when I say supply chain, I mean in the sense of supply chain optimization, not just management in the sense of just, accounting for things. Which is you need to have programmatic expressiveness if you want to have something that has any chance to deal with real-world supply chain. And in this book, I believe that one of the things that is very interesting is that instead of going super deep on idealized supply chain, where you say, oh, let's have like a mathematical proof of optimality for this or that for an idealized supply chain that just will never exist, and where if you add a bit of real world ingredient into supply chain, all the mathematical frameworks just falls apart. Nicolas is doing some things that I believe to be much more on the hacker mindset, which is much more appropriate. Is just show how you can provide very simple and straightforward numerical recipes with Python, which is to address real-world situations. And the beauty of the recipes is it's very hands-on and literally shows that most of the classic supply chain recipes can be literally implemented in like 5 lines of Python or so in most of the time. And I believe that's very interesting because it conveys the idea that if you want to do something very simple, it can be done in very simple ways where it doesn't take half a dozen of software engineers to come up with those things. And I believe that as a side effect, it kind of, I would say, profoundly demystifies what large software vendors are actually pushing to the market, because when you show that basically you can do what they are saying that they are doing, but just in a few lines of code, the question is there any value to what is being proposed by those vendors? And I believe to a large extent, no. And but even beyond that, it shows that if you can have very small building blocks, and suddenly you can combine them to inject your bits of real-world challenges into those recipes, so that you have something that has at least a decent chance to be a suitable solution for your supply chain.
Okay, sounds certainly very interesting, Nicolas, this idea of just a few lines of code and you're already getting kind of results, and much more kind of satisfying than spending hours and hours kind of looking at coding. So who is this book kind of aimed at?
So one of my big obsession is simplification, right? So when I write such a book, I'm trying to think, okay, if I manage a supply chain and I want to get some, let's say I want to optimize inventory, right? I'm trying to basically simplify everything to give you a global picture, and yet at the same time, allow practitioners to do it themselves. So I'm really writing this book for anyone in a supply chain right now that is thinking, oh my God, we have too much stock, or we have so much stock, and at the same time, we don't have the right service level, or simply, well, I'm in charge of the stock, but I have no idea how much I need, right? I really wrote this book to help those people to basically, as I like to say, to do it themselves, right? You have so many do-it-yourself section to show in this book in the simplest way how you can do it. And yet, at the same time, I'm really trying to tell them, well, we have to take some assumption, and as we follow some assumption, we are not aiming for perfection, that wouldn't exist. So we're gonna do some simulation and we're gonna see the limit of the model we do. Right? So in short, this book is really for anyone in supply chain today who's thinking, okay, I need really to get the inventory correct.
Okay, great. And it's a bit of a change of a mindset, isn't it, really, Joannes? Because historically, maybe programming was something that was kind of left to kind of IT departments. Now it seems that there's more and more practitioners that are kind of adding those strings to their bow. So why would you say there is this kind of mindset?
So I believe, you know, those things have been around for a long time. But for also, you know, in terms of supply chain maturity, for decades, companies were just struggling just to have the digital counterparts of the supply chain, just to have, I would say, an ERP or WMS setup where you can just have the stock levels, you know, that are managed in a I would say in a straightforward manner. No intelligence whatsoever, but just you have like a digital, an accurate digital counterpart of your supply chain. It took a long time for, I would say, us to get there. If we look at the fact that the first ERPs were deployed, they didn't went by this name by the end of the 70s, but you know, so literally we are 4 decades, you know, we have 4 decades of ERP histories under our belt nowadays. So it took a long time to have, I would say, sufficient maturity, sufficient digital maturity, so that it would become like a reasonable options to do all the sort of optimization. And basically it has been, I would say, a slow move from Excel to Python. By the way, Excel gives you already a lot of programming capabilities, which are also to some extent illustrated in the book. So it's not, for me, it's a continuum. It's not necessarily a complete disruption where you go from something where you have programmatic expressiveness that let you, and again, why do you need this programmatic expressiveness? Is just to cope with all the things that the real world is throwing at you. You know, there will be things that are completely random and unpredictable. It can be a Brexit, it can be, you know, Trump tariff, it can be a pandemic, it can be suddenly the fact that the company has to deal with the distribution of a vaccine, and it's going to turn your supply chain upside down. And so there are a lot of stuff that happens, and if you just have like a rigid piece of software, it's just not going to be able to cope with all the things that happen in the real world. So you need to have something more expressive, and thus you need to have this programmatic expressiveness. Excel gives you, that, but it comes with certain limitations that are, I would say, profoundly related to the way you organize your logic in a spreadsheet. So Python gives you the next level. It's a bit more abstract, but you get, I would say, the next level of expressiveness where you can have, I would say, you know, things like user-defined function. I mean, you can have that in Excel through Visual Basic, but VBA. But, you know, for all intent and purposes, Python is just, you know, kind of a superior flavor of VBA.
Okay, Nicolas, let's talk about maybe that from continuation from Excel to Python. There's plenty of other sort of programming languages out there, things like SQL, C#. So why is it that Python was kind of your languages of choice for this book? I mean, what does it provide that perhaps some of those other languages don't?
Well, overall, we see that Python has a few advantages. The first one is that it's actually kind of well known. I don't know if you could say it's #1 language in the world, but it's at least close to. It means that today, if you ask yourself a question about Python, you just Google it, you're going to find an answer. And this is really convenient, right? If you find a programmation language that, let's say, it's much faster than Python, so you would say, okay, I'm going to use this one, it's faster, but you get some question, and you type those questions online, but you see no answer, you're going to get stuck. With Python, it's extremely difficult to get stuck because I can really tell you that someone somewhere already had the same question and it had been answered already, right? On the other hand, and I think this is extremely important, I said I'm really into simplification. Python is really simple, right? I always remember from my day as a supply chain analyst, those kind of colleagues that used VBA. I mean, we all have, many people have in mind this kind of huge VBA macro file in Excel that everyone is kind of afraid of it, and you don't dare to touch anything in the Excel file because if it's breakdown, it's impossible to fix it, right? Python is nothing like that. Well, Python is much simpler, and you can basically read it and understand what it does just as you keep on reading the file. I had 1 or 2 readers writing me a mail after reading the book telling me, Nicolas, I don't know anything about Python, but I read your code and basically I understand what you do in your code because, well, everything is super clear. So thanks to these 2 things, I think Python is really the language to use if you want to learn something new. Now, concerning the book, why am I putting so much emphasis on Python? Well, I see 2 reasons why I'm doing this. First, I believe that if you want to learn something, you need to practice, right? It's one thing to go to a classroom and look at a prof, a trainer, trying you some math, some theory, some graph. That's one thing. But I think it's much, much better if you can experience it by yourself, if you can try it out by yourself and so on. So I'm pushing in the book so many do-it-yourself section, either in Excel or Python, because I really want the reader to acquire some new know-how and knowledge, and I want them to try it out by themselves. I also want to demystify this thing, telling them, well, you know what, it's not so complicated. You just type a few lines of code and it's going to work on your own computer. So that's one thing. That's the main thing why I'm really pushing Python in this do-it-yourself section in the book. The second thing is that I also want to show to all the readers that, well, actually, thanks to Python, you can easily scale this solution to some supply chain. So you can easily not just do an exercise on a piece of paper saying, okay, great, I just solved this inventory optimization for 1 item. No, with Python, you can easily, or with any other programming language, actually, you can easily scale that so that you can basically run a supply chain from using some, again, assumption and simple model, but you can do it using Python.
Okay, would you agree with that, Joannes? We've obviously kind of spoken a bit in the past about some of the limitations of Python. So where can you do maybe better?
So, I mean, first, indeed, in terms of popularity, there is no question that, Python is in the top 10 of, the most widely used programming languages nowadays. Contenders would be, JavaScript and Java. And none of those, and probably a few others, but they are not, I would say, clearly, they are not good options for supply chains, mostly because it takes, I would say, significant software engineering skills to do anything with those languages. And it's very funny because to some extent, some of the good qualities, for example, of Java, which is extensive support for object-oriented programming, can be a defect when it comes to easily onboard new users, because you have pile of features that are not they are not readily useful for supply chain optimization or supply chain modelization purposes. So if you just throw that into the mix, you just have something that is more complex as a programming language, as a tool, for no obvious, I would say, upside, at least not, not for the first few months of pretty much any project. And then, so there are these sort of things. Then a bit, I would say, accidentally, Python was started in the 90s, and it's not a new language. It took, almost 3 decades to basically achieve any degree of popularity. So it was something that's very slow in the making. And it's interesting because there was like a massive migration from Python 2 to Python 3, where it was, I believe, kind of a takeover by academia, where suddenly, Python had found its sweet spot, and its sweet spot was actually academia, and something that would be easier. And basically, what the big transition, if I want to summarize, between Python 2 and Python 3 was to remove all the bad parts of Python that were kind of, I would say, the odd bits of Python. But the bottom line, what emerged from that, it was basically during the last decade, was a language that was much more in line with what you need in academia. And what you need in academia is something where you have something that is very concise, where you don't have too much mass with too many things floating around. The exact opposite of that would be probably something like C++, where I'm not sure if there is anybody on earth that says, I know all there is to know about C++, because the language, the specification of the language is so absolutely gigantic that I don't think it's even humanly possible to be familiar with all the parts of C++, just C++, the language, which is kind of insane when you think about it. So all of that put together, you have Python that is really a sweet spot, to let people start I would say, readily. And I believe that that's a good starting point to avoid, a lot of the pitfalls of accidental complexity. Now, I believe that it's not necessarily the end game, though. And that's, by the way, what we have been developing at Lokad. But obviously, this is not the topic of the book of Nicolas. But so I'm not going to digress too much. But I believe that if you want to cope with uncertainty, there are plenty of things that can be done relatively simply in Python. But if you're willing to go as far as modifying the language itself, it could be done in ways that are even simpler. But it goes beyond the book, beyond, I would say, the scope of the book. I think for the purpose of the discussion, I think right now that all things considered, if you have to choose between, I would say, what you can get from Python versus most of the expensive options on the markets, it's literally a bargain, and there is very little reasons not to at least give a serious try. At least, even if you fail, it will be a much cheaper failure compared to failing with an SAP of this world.
Okay. Nicolas, as well as looking at some of the sort of the models in your book also looks at some of the confusions when it comes to sort of inventory optimization. So what are kind of the common confusions that we should be aware about in the industry?
Yeah. With my experience as a consultant, discussing with many practitioners on how they deal with inventory optimization, and when you look at, this safety stock formula that you see everywhere, even on Wikipedia, right? You see people going on Wikipedia and typing safety stock, looking at the formula, and then typing it into Excel. And what we see there is that, and this is correct, when you want to assess how much safety stock you need, you're going to take a look at the lead time. So basically, how long does it take to do a replenishment? While people, first confusion is that I see that many practitioners confuse the whole concept of lead time and transportation time. It might just take 2 days or 1 day for a truck to go from one warehouse to another, but it might take 3 weeks of planning because you need to find a truck, you need to find a driver, and you need to have the picking time and all these kind of things that piles up, and in the end you take 3 weeks. But there is still one thing that people always tend to forget in supply chain, is that you shouldn't just take a look at the lead time, but you should also take a look at the review period. Well, let me give you an example. If you make an order every week or every month, that's an addition of what I call in the book the risk period. So basically, the period against which you need to be protected increase by the amount of the review period. So if you only do a new replenishment every week and you have a lead time of 3 weeks, the risk period is actually 4 weeks. So you need to be protected over what could possibly happen over 4 weeks. What I see is that most of the people, most of the software tends to totally use and bypass this review period and will just focus on these 3 weeks of lead time. So I'm trying really in the book to emphasize the fact that, you absolutely need to take into account this review period when setting the safety stock. But also I'm pushing people to realize that actually, if they can reduce this review period, if they can reduce the frozen period for production and so on, they basically are allowed to reduce safety stock, which I think it's kind of a good win for a supply chain.
Okay, and would you agree with that, Joannes? Would you say that there's a lot of confusion out there and that's why people are so happy to pay for sort of inventory software?
Yes, I mean, again, I believe that, my belief is that supply chains desperately needs, I would say, better classes of engineers. And in the first lectures, I had this introductory joke that you have if you have a lot of energy, you go to sales. If you're reliable, you go to production, and if you're lacking all sorts of qualities, you end up in supply chain. And but the thing is, if I compare certain domains. In supply chains, the sort of confusions that you encounter are not, I would say, the product of exceedingly brilliant minds. And I'm sorry to be maybe a bit tough to the audience, but if you look at, let's say, for example, what is being done with lithography for microelectronics and the sort of problems that those people are solving, they are mind-blowingly complicated. It's literally, you have everything. You have quantum physics with impossibly complicated math, and frankly, it's way more complicated than what is being the sort of problems that are being tackled in supply chain. You have physical problems where you have all sorts of difficulty. The technology is literally, you have so many super complicated pieces of tech that you have to bring together. I mean, for example, what sort of companies like ASML are doing in the Netherlands. I mean, it's almost magic because it's just, I would say, it's a sort of achievement of mankind when you have like the most brilliant minds put together. But and so I believe, you know, but the challenge is that if you want to have, you know, smarter people coming to supply chain, so that we can attract, you know, very I would say brilliant minds that are not going to be confused by problems as, you know, as dumb as just a definition of the applicable period for your inventory replenishment, you know, system that you're about to model. We need to have to frame the problem in a way that those people can exercise your intelligence. You know, because obviously, if you have if your entire discipline is about, you know, turning dumb buttons, you know, on dumb pieces of software, then don't get too surprised if in the end the only employees you get are not, you know, the most brilliant ones. So I believe that, and that's also something that I like about this book is that, you know, I think the book of Nicolas is that it gives something where if you're smart, if you're young, if you have some degree of enthusiasm, then you can get really genuinely interested by the sort of problems that you will tackle. And not only you will, by reading the book, you know, you can actually get better at solving those problems, which is very good. But for supply chain as a whole, it's the sort of things that can make the whole field more attractive to brilliant minds who want to exercise, you know, their minds on interesting problems in the first place. And so what I suspect that in terms of confusions, you know, the sort of things that confuse people now and what the sort of things that I hope will confuse people in 2 decades from now will be radically different, especially if we bring, you know, I would say a lot more talent to this industry.
Okay, if we start sort of wrapping things up a little bit. Nicolas, in your book, Joannes sort of mentioned that some of the models that are used have their very much kind of applications, maybe from an academic perspective, but maybe in the real world, they have their kind of limitations. Would you say that some of these limitations can be overcome, and how can they be overcome, and how can they end up being used in kind of the real world?
Well, you always have to understand that somehow a model is a simplification of the reality, right? So from really the base, when you start a model, you have to understand that you have to leave some things aside. So the real question is, okay, if I take a model that works, let's say 90, 95, 98% of the time, is it good enough for me? Someone would argue, yes, it is, or no, it isn't. Now, if you do a model and you see that it only works at, let's say 70%, 60%, then you really realize that, okay, the usual mathematical model is not good enough. I need to move on to something else. And this is what I show in the last part of the book, saying that at some point, mathematical model will not be good enough. I mean, will not be accurate enough, will not be tractable, meaning that they're going to get too complicated. So you might go to simulation. And I'm quite sure that Joannes has so much to say about how to do simulation in supply chain. But from this first part of the book, I'm also showing, okay, those are the usual model for supply chain. Let's do some simulation to see if they work, yes or no. And I really see there that, for example, one of the things that we usually do in supply chain, it's taking this, again, this usual safety stock formula, the one that's on Wikipedia. And this formula can deal with random lead time, meaning that, well, from time to time, your supplier is late, so you should have some more safety stock, right? When actually you look at the formula to assess how much safety stock you need based on random lead time, you see that there is a whole assumption that says, well, lead time are normally distributed. So basically, it's a well-behaved curve that your supplier, from time to time, it's too late, but never so much late. Actually, in practice, I believe that most of the supplier, most of the time, are in time, but then when they're late, they're quite late, right? So I would say 80% of the cases, they're on time, and then 20% of cases, well, they can be 1 or 2 weeks late. Well, actually, there is no mathematical formula that is able to deal with this, right? So if you have such kind of supplier, you will not go anywhere with this safety stock formula. You really need to go back to simulation. And this is really where you have the limit of using some easy mathematical model and the limit of, well, we should go one step beyond and maybe start to use simulation to solve this.
Okay, brilliant. We're going to have to leave it there, but thank you both for your time. If you're interested in reading Nicolas's book on inventory optimization models and simulations, we'll put a link in the description below. Otherwise, we'll see you again in the next episode, and thanks for watching. Bye-bye.